Okay, let's go over the study guide. So it says, use the graph to the right to determine whether each system has no solution, one solution, or infinitely many solutions. Well, we have x plus y equals 3. That is this line right here. And we have y equals negative x plus 3. And that's this line here. Since it's the same line, it is infinitely many solutions. Okay, then the next one is, let's change color. It is 3x minus y equals negative 3. So it's this line. And we have 2x minus 3y equals negative 2. That's this line. So they're going to cross right here. And so that would be one solution. All right. So now let's talk about number 3 and 4. Okay. So it says graph each equation, then determine whether the system has no solution, one solution, or infinitely many solutions. If the system has one solution, name it. So we have y equals negative x plus 3 and y equals x minus 3. So first we need to graph these. So we have the first one, we're going to start at the y-intercept of 3. We have a slope of negative 1. So one of the directions have to be negative because it's going to be like negative 1 over 1. So down 1 over 1 would go here. And so it's going to be something like that. Okay. And then we have y equals x minus 3. So we go down here to where the y-intercept is negative 3, and our slope is up 1 over 1. And so it's going to be something like this. So we're going to have one solution. And to name it is the solution where it sets, and that would be 3, 0. Okay? Because that's right here where they cross. All right. Number 4 is a little bit different. First, you would want to get the equations in y equals mx plus b format. So the first thing I would do is take my 2x minus y equals 5, subtract off 2x from both sides, and that's going to give me negative y equals negative 2x plus 5. Then divide everything by negative 1, and I get y equals 2x minus 5. Well, I could go ahead and graph that line. So that's 1, 2, 3, 4, 5. Puts me where it crosses the y-intercept at negative 5. And my slope is 2, so up 2 over 1. And that's going to put my line something like this. Okay? Then we look at the 4x. Let's change the color to make it easier to see. We have 4x minus 2y equals 10. Subtract 4x from both sides, and I get negative 2y equals negative 4x plus 10. I then divide by everything by negative 2, and I end up with y equals 2x minus 5. Oh, look, it's the same. And since it's the same, that means it's the same line. So this would be infinitely many solutions. Okay, so now let's take a look at number 5. Read the instructions. It says use substitution to solve each system of equations. If the system does not have exactly one solution, state whether it has no solution or infinitely many solutions. Well, I can take a look at this, and if I'm going to do substitution, I'm going to look at this equation because I have this y with no coefficient. So I just need to solve that for y equals whatever, and then I can substitute that into the other equation. Okay? So let's take a look. That would be 2x minus y equals 3. I subtract 2x from both sides, and that gives me negative y equals negative 2x plus 3. Divide everything by negative 1. So I have a positive y, and I get y equals 2x minus 3. Now I can substitute that in for the other one. So I take the other equation and I say 5x plus 7. There's a y, so I have to substitute in 2x minus 3, and that equals 17. I distribute, so that's 5x plus 14x minus 21 equals 17. Now I can combine my like terms and get 19x minus 21 equals 17. Add 21 to both sides, and I get 19x equals 38. Divide both sides by 19, and x equals 2. Okay, so I know my x is 2. I have to find my y. Well, I can go back up here into my equation and put 2 times 2 minus y equals 3, or 4 minus y equals 3. Subtract 4 from both sides, and I end up with negative y equals negative 1. Divide everything by negative 1, and I get y equals 1. I know that's kind of hard to read over there, but y would equal 1. So I'd have a solution set of 2, 1. Okay? All right. So let's go ahead and get this off here. Number 6 and 7 is to use elimination to solve each system. So we'll take a look at this, and we have a positive 2y and a negative 2y. So if I add those two together, I'm going to get 0. So let's add. And 2x plus 3x would be 5x. And that would equal 6 plus negative 11 would be negative 5. Divide both sides by 5. And x equals negative 1. So then I go back up and I can say 2 times negative 1 plus 2y equals 6, or negative 2 plus 2y equals 6. Add 2, and we have 2y equals 8. Divide both sides by 2, and y equals 4. So my solution set would be negative 1, 4. Okay? So, let's get rid of some more of this. Let's change color. All right. So then we have this one. You notice that the 3y's on both equations are both positive. So I could use subtraction and eliminate the y's. So 7x minus 9x would be negative 2x. The 3y's eliminate. And that would give me 1 minus a negative 3, or a positive 4. Divide both sides by negative 2, and x equals negative 2. Then I just plug that back in. So 7 times negative 2 plus 3y equals 1. Negative 14 plus 3y equals 1. I would add 14 to both sides, and I get 3y equals 15. Divide both sides by 3, and y equals 5. So my solution set would be negative 2, 5. Okay? All right. So now for number 8, I need to determine which method is the best and then solve it. Well, if I take a look, I have a 5x and a 5x, and they're both positive, so the best method would just simply be to subtract. And that would end up giving me a negative 11y equals a negative 11. So then I would divide both sides by negative 11, and that gives me y equals 1. Okay? Now I can go back up to any of them and plug it in. So let's go 5x minus 4 times 1 equals negative 9. 5x minus 4 equals negative 9 plus 4. And that gives me 5x equals negative 5. Divide both sides by 5, and x equals negative 1. So my solution set would be negative 1, 1. Okay? And now number 9. The sum of two numbers is 16, and their difference is 20. What are the two numbers? Well, the sum of two numbers, so that's x plus y equals 16, and the difference is x minus y, because that's subtraction, is 20. Well, I can either add or subtract, so let's just add. That would give me 2x equals 36. Divide both sides by 2, and x equals 18. So 18 is one of my numbers. And then I could simply say x plus y equals 16, or 18 plus y equals 16. Subtract 18, and y equals negative 2. So 18 and negative 2. All right, let's go to the next page. So number 10 says for question 10 and 11, solve the system equations by graphing. So we're going to graph. All right, so on the number 10, we know that it's going to go, the y-intercept is going to be positive 1. So it's going to be right here. And then I have a slope of 1/3. So up 1, 2, 3, over 3. Okay, it's going to be a dotted line. All right, and it's going to be shaded down here, okay? Now the next one is going to cross at negative 3. 1, 2, 3. Let's change colors. Let's go red. 1, 2, 3. We go right here. It has a slope of 2. And it's going to be a solid line. So it's going to be something like this. And it's going to be all of this area. Okay? So therefore, let's go green. This would be the area that overlaps and needs to be shaded in. Okay? And that's how you would do it. All right, number 11. We would have y is less than or equal to x plus 3. So we're going to start at where y equals 3. And we have a slope of 1. And it's a solid line. Okay? And it's going to be shaded down here. And then we have y is greater than negative 1/2 x minus 2. So we'll go down here to negative 2, where it's going to cross the y-axis. We have a slope of negative 1/2. And it's a dotted line. And it's greater than, so it's all of this area. So the area that needs to overlap or shade would be all of this between the two lines that overlap. Now, just for a bit of advice, how I could check that is I could pick any point in that overlapping area, and it should work for both equations. If it does not work for both equations, then you have the wrong area shaded, okay? So for example, 0, 0 is inside the shaded area. So 0 is less than or equal to 0 plus 3. Well, 0 is less than 3, so that checks. And then 0 is greater than negative 1/2 times 0 minus 2. Well, 0 is greater than negative 2, so that checks. So I know that point is within the shaded area. Okay? All right. Number 12, to qualify for a certain car loan, a customer must have a credit score of at least 600. In addition to the cost of the car must be at least $5,000. Define the variables. So there's step 1. So let's define some variables. We could say x equals the credit score. and y equals price of the car, or cost of the car. Okay, so I've answered step 1. Now we need to write a system of inequalities to represent the situation. Okay, so that's next. So I know that the credit score must be at least 600. So it can be more than 600, but it has to be at least 600. Well, that would be x is greater than or equal to 600. Okay? And then I know the car must be at least $5,000. So it could be more than 5,000, but it has to be at least 5,000. So that would be y is greater than or equal to $5,000. Now finally, the question asked me to name one possible solution. Well, one possible solution could be a 700 credit score. That was terrible. And a $6,000 car. Okay, so it just has to be, it has to answer what the problem says. Okay, so the credit score has to be 600 or above, and the car has to be 5,000 or above. Any two numbers would work as long as it meets that parameter. Okay, all right. Now, Kyle started a new job part of the way through last month. That pays $7 per hour. He began the month making $5 per hour at his old job. Kyle worked a total of 54 hours last month and made $338 before deductions. So how many hours did he work at his new job? All right, we need a couple of equations to try to figure this out. All right, so we know that he worked at a job. We know that he worked at 2 jobs. And we know the number of hours that he worked at the first job plus the number of hours that he worked at the second job is going to equal a total of 54 hours. Okay? So that simply could be x plus y equals 54. Okay? Because x is going to be the, for me anyways, is going to be the new job. And the y is going to be the old job. Okay? All right. Now I need another equation. Well, I know that the new job pays $7 per hour. Well, x is the number of hours for the new job, and y is the number of hours for the old job. So I could say 7x plus his old job was $5 per hour, 5y, and we know together they equal $338. All right. Now I can take a look at this and I can solve this. I can solve this a couple of different ways. One way I could solve this is simply by substitution. Well, I want to know how many he worked at his new job. So I want to know how many he worked at x. So I want to solve for x, so I want to get rid of the y. So I could take my x plus y equals 54, subtract x from both sides, and now I get y equals negative x plus 54. So now I can use substitution. And I can say, I can substitute it in for the y. So I could say 7x plus 5 times negative x plus 54 equals 338. Or 7x plus, 5 times a negative x would be minus 5x. And then 5 times 54 would be 270, I believe. And that equals 338. Combine my like terms, and let's move over here. So I can combine my like terms, I would get 2x plus 270 equals 338. Subtract 270 from both sides, and I get 2x equals 68. Divide both sides by 2, x equals 34. So the answer would be 34 hours. Okay? All right. Let's look at the last one. It says Brent has $3.35 in quarters and dimes. If he has 23 coins in all, find the number of quarters and dimes. So we need to write two equations. All right. We have all the information we need. So we know we have a total of 23 coins. Some of them are quarters, and some of them are dimes. So however many quarters plus however many dimes, we have 23 altogether. Okay? All right. So we also know that quarters cost 25 cents each. So 0.25 quarters plus, we know dimes are 10 cents each, right? So 0.10D, and if we add those together, we get a total of $3.35. Look there, we have two equations now. Now we can solve this thing. We could do the same thing if we wanted to. We could use substitution. Sounds good to me. So we can change this one to, if we subtract a Q from both sides, would be D equals 23 minus Q. Okay? So we're getting too much blue. Let's change colors. So let's substitute it in. We would get 0.25 Q plus 0.10 times 23 minus Q equals 335. Okay? All right. So we distribute, and we get 0.25 Q plus, that would be 2.3 minus 0.10 Q equals 335. Okay? Once we combine our like terms, and we can move right up here, we would get 0.25 Q minus 0.1 Q. That would be 0.15 Q plus 2.3 equals 335. Okay? 300. Oh, sorry. Forgot my decimal in there, didn't I? So 3.35. Then we subtract 2.3. That leaves me with 0.15 Q, and that equals, what? 1.05. And then we divide that by 0.15. And then Q will equal 7. Okay? Then I go back up here and go Q plus D equals 23. Q is 7, so 7 plus D equals 23. Subtract 7, and D equals 16. Let me erase this. And so I would have 16 dimes and 7 quarters. Okay? All right, if you got any questions, let me know. Otherwise, study, study, study. See you tomorrow for the test.